Let us discuss one more topic here in formal language and automata theory. Formal language and automata theory. So the topic is that construction of NFA without epsilon. From NFA with epsilon. We call here epsilon it is. Okay. So this is the major topic of discussion. Let us take one of the problem here. Here is a finite state machine having three states. How many states? One is called Q0, another is called Q1, okay, another is called Q1, another is called Q2. Let us having three states and epsilon move from Q0 to Q1, epsilon move from Q1 to Q2. It is the initial state or start state. This is the final state. And there is a loop, self loop on 0 transition, self loop on 1 transition, self loop 2 transition. So what is the question here? This is NFA with epsilon. This is the most important thing to remember. And what is our target? Our target is NFA, construction of NFA without epsilon. That is the very important thing. So what we did here, the very first step, we have to find the epsilon closure of each state. Each state. What is we are finding here? Finding epsilon closure of each of state. So that is the thing here, each of state. So now here you can see that we have find epsilon closure of Q0. So what do you mean by epsilon closure of Q0? The definition says that closure of any state Qi is a set of, what is that? Set of all the states P set of all the states P through or reached through epsilon, reached through epsilon path. Epsilon path. What is that epsilon path here? You can see that Q0 to Q1 there is an epsilon. From Q0 to there is a path from Q0 to Q2 on epsilon path. Remember that I said it is epsilon path. Epsilon path. Right? So what is that idea? I can write one convention of that. We can use one of the convention that del cap of, what is the del cap of, that is q0 on epsilon, that is equal to q0, q1, q2, del cap of q1 comma epsilon is equal to q1, q2. Similarly, del cap of q2 on epsilon is equal to epsilon closure of q2. Again, I write one of this. So what we have written here, del cap of q0 epsilon, del cap of q0 epsilon, that is equal to epsilon closure of, what is that, epsilon closure of q0, that is equal to q0, q1, q2. Similarly, we have to find del cap of q1 epsilon, epsilon closure of q1, that is equal to, you can see that. So what is the idea? That all these state that is reachable through the epsilon path. So here we can write here that is equal to q1 comma q2. Similarly, del cap q2 comma epsilon, that is equal to epsilon closure of q2, and only q2 is left out here. So one of these things you should also, you can construct the transition table for this. You can construct the transition table for this. You can construct the transition table for whom it is constructed. It is for NFA with epsilon. So what is that we have written here? Rows for state and columns, and these columns you can see here. Okay, columns for input. What the inputs are here? 0, 1, 2, epsilon. So 4 column is being specified here. Accordingly, according to this NFA with epsilon, we have constructed this transition table NFA with epsilon. Now, what is the property? The rules of rules for conversion. Rules for conversion from where to where? From NFA with epsilon to NFA without epsilon. So that is our main objective. So if you see this machine NFA with epsilon, which is defined with 5 tuples: Q, input alphabet, setup states, input alphabet, and Q0 is the initial state, and transition function del, and set of final states. So here major thing that the transition rule here, if you are in the state Q and either, what is that idea, you are consuming alphabet or epsilon, you may go to multiple states here, that is 2 to the power Q. So what we are to construct here now, new machine, that is NFA without epsilon What is that? NFA without epsilon. So that is del dash. How do you write here? Let it is called NFA into Q input alphabet, Q0, del dash and F dash. So what is the meaning of this? And the transition function, the major rules here, del dash is here. From any state you can transit on input alphabet, no questions of any epsilon here. You may transit to multiple states, 2 to the power 0. So that is the rules here we have written. So this is the rules which we have written here, right? Now what we have to, what are the tricks of construction here? Tricks of construction, tricks for construction that what you have to do, things for construction. Remember here, whichever I am writing here, these, even if I am writing here Q dash also, right? Q. So what is talking about? The number of states in both of machine should be same. Okay. Second, that input alphabet that is sigma is also same. That is here, what is covering here? This is 2. Third is that initial state is also same. Initial state is also same. So what is the difference only? Difference is in transition rule and that is del dash and final states. Or set of final states. Okay. So that I am coming to now del dash transition on that. So if you see here, in this particular machine for construction, now let us construct. Now let us construct. How many possible transitions will be there? Del dash Q0 on input 0, del dash Q0 on input 1, del dash Q0 on input 2. It of course, which one this? For Q0 state. Q0. Similarly, we can write here for Q1. For Q1, what is the Q1? Can have transition here, del dash Q1 comma 0, del dash Q1 comma 1 and del dash Q1 comma 2. Similarly, we have one more transition here for Q2. Now del dash Q2 comma 0, del dash Q2 comma 1, del dash Q2 comma 2. Now this is very important. Now how we are constructing? See here in this particular picture we have explained here for what this diagram talking about, del dash q0 on 0. What is the rule we have written here? I will show one of the examples how it is written. That is, what is written here, del dash q0 0. We also can write here epsilon closure of del cap q0 epsilon comma on 0. Try to see this picture here. This is bracket. How many bracket it has been closed here? You can see this bracket is closed here, this bracket is here closed, and this bracket is also closed here. Now if you see one analysis of this, I can write here epsilon closure of del of, I can write here, what is that, q0 epsilon we have written here, that is equal to q0 q1 q2 and on transition 0. You can see here the figure here. So you can see that we are getting here one I will write for you, epsilon closure of, let me write here q0 comma 0 union q0 q1 comma 0 union del of q2 comma 0. Please look at here everybody, how I have written here union operation. What operation? Union operation. So what is that? Epsilon closure of, look at q0 0, q0 on input 0, it is q0. Look at q1 on input 0, no input, it is phi. Look at q2 on input 0, there is no 0 transition for this, so it is phi. And so it is epsilon. All of you know that union with phi is the same q0 here, so you can write here epsilon closure of q0, that is equal to, what is that, q0 comma q1 comma q2. So when we are trying to construct this machine, so what is this machine we will construct here? There are same 3 states, we are not going to change. This is q0, q1, q2, and what you have to do here for this, so for 0 transition, where it will go? To the same state q0, it will go to the q1 state, it is also going to the q2 state. So this is the major part of that. Similarly, you can see here we have written for q0 comma 1. On q0 1 transition, I got it answer here, that is equal to q1 comma q2. Same policy to be applied here. So now q0 on input 1, it is going to the state q2. On input 1, it is going to the state q1, and on input 1, it is also going to the state q2. That is the idea about that. Similarly, let us go for, now what we have completed here? We have completed q0 state. Similarly, you can go for the q1 state here. So what is that idea for q1 state here? So what is that idea? That is del dash q1 of 0. If you see my figure analysis, del dash q1 comma 0, you are getting here phi. So there is no transition for 0 from q1. Similarly, let us see for 1, where it is going here, it is going to the state q1 comma q2. So what I will do here, on input 1, it is going to the same q1, also it is going to the state Q2. Now let us go for Q1 on input 2. It is very much clear that it is, let us took it here. Is it 5? No, it is not 5 here. What I did here for Q2, because Q1 we are finding the Q1 here. Let us check here, epsilon closure. Here we have already known that this is Q1, Q2 on input 2. So how many bracket here we have written here? Epsilon closure of del of Q1 comma 2 union Q1 Q2 comma 2. Yes, you can see that this is epsilon closure, this is phi union Q2 on 2, Q2 on 2 we have seen here, Q2 on 2 is Q2, hence it is Q2. So epsilon closure of Q2 is equal to Q2. So that we have seen in this part. So on input 1 from the state Q1, it is going to the state Q2. This is an idea about that. Now we have completed for Q1. Now let us go for Q2. Let us go to Q2 here. Now Q2 state. So here del dash Q2 on 0. You can see here from the state Q2 it is phi. So no transition for 0. Del dash for the state Q2 on 1. You can see here at this picture we have written here, it is again it is phi. That is from Q2 on 0 no transition, Q2 on 1 no transition, from del dash Q2 comma 2. Now let us check here what we are getting. It is called Q2. So it concludes that Q2 on the input 2, it is going to the same state 2. Now put 2. Here one thing I am missing. You can see that on Q0 on input Q0 on input 2, I think I have missed one thing here. Q0 on input 2, you can see that Q0 on input 2, it is going to the state Q2. So that is the most here to be written on this part. So now we have seen that the complete construction of transition part is over for this all the states. Now if you see this diagram here which you have done for this machine, we have completed for del dash. Now let us go for the f dash. So what is the rules for the f dash here? Now the rules for the f dash, I will show one of the rules here. For f dash, what is written in the final state f dash here? That is, let there is an S, epsilon S in NFA with epsilon. So what are the edges are here? You can see that there is the edge here Q1. If you look the previous figure here, Q1 to Q2, there is an epsilon move. And what is speaking about that? Let there is an edge epsilon in NFA with epsilon machine, and what that? And Q2 is the final state. So that is Q is the final state here. There is a transition from P to Q on epsilon, as well as Q is the final state. Q is the final state. And Q is the final state. So here Q2 is the final state. You can see this figure. is final state. Then Q1 is also final state. So what I have to do here in this figure, Q1 is also final state. So if you, where we are drawing the figure here, now Q2 is the final state, and hence we make Q1 is also final state. Similarly, how many such epsilon moves are there? Number 1. Number 2, Q0 to Q1. There is an epsilon, and Q1 is final state. It is also final state. Then Q0 is also final state. So for that, what we did here, we make it Q0 is also final state. And this way, this is the final version of a final construction of NFA without epsilon move. So very, very important. Thank you so much.